Right, so we know that if you have y equals natural log of x, the derivative is going to be 1 over x, right? Um, but what if the log argument is more than just x, okay? Then we have to use the chain rule, okay? So example over here, look, if you have y equals natural log of x squared minus 5, how do we do this? We have to use the chain rule. So here's the derivative. You will do 1 over x squared minus 5 first. So it's always 1 over x, the log argument, okay? But don't stop there. Whenever that log argument is more than just x, like in this case it is x squared minus 5, you need to take the derivative of that and multiply by it. So what is the derivative of x squared minus 5? 2x. So your answer is 1 over x squared minus 5 times 2x. So if you want to simplify your answer, you can just put this 2x on top of it, and that is the derivative of this function. But if you have log function whose log argument is more than just x, you have to do the chain rule. Okay, so let me show you one more. You start by writing 1 over that log argument first. So you write 1 over this 5x squared minus 3x plus 7. So that's half of the answer. But now you multiply this by the derivative of this blue part, this log argument. And what's that going to be? That is going to be 10x minus 3, right? So when you simplify, this derivative just go to the top of the fraction. Ta-da. And that's going to be your final answer. So it's the chain rule. If you have log argument that is more than just x, make sure to take the derivative of that log argument and multiply your answer by it. Okay? So maybe one little different. This is a little different. Let me think. Have you guys know this rule? I think. If you have y equals natural log of x to the 8th power, did you know that you can bring this 8 down to the front of natural log and write it as y equals 8 times natural log of x? That's one of the log properties that you talk about in pre-calculus class, but I want to use that in this problem right here. I want to use that in this problem. I want to bring that 8 down to the front because x is getting raised to the 8th power, and this is in the log argument, so I will bring this 8 down to the front. You don't have to if you didn't realize that, but I think that's going to save us lots of time. So give me 1 second. Let me go ahead and do that. So this 8, bring it to the front and let it just wait. So here's my new y. Y equals 8 times natural log of, now what's left inside? If that 8 goes down, I have x over 5. But you agree x over 5 can be written as 1 over 5 times x, right? I'll write it that way. Alrighty, let's take the derivative of this now. Y prime equals 8 times. If you take the derivative of natural log of something, it's always going to be 1 over that something. So you write down 1 over 5x in the denominator. But you need to now multiply this by the derivative of the inside part. Okay, what is the derivative of 1 over 5x? Well, that's going to be 1 over 5, right? Now, guys, I was getting a little concerned about this ugly 1 over 5x. But hey, look, it's perfect. This 1 over 5 over here and that 1 over 5 over there, they're going to cancel out. Because the first 1 over 5 I was dividing by 1 over 5. The next 1 over 5 I'm multiplying by 1 over 5. So dividing by, multiplying by, they're opposite. They cancel out. Alrighty, so let's write our final answer then. Y prime equals, let me put this 8 on top of the fraction, okay, because we're multiplying. So I'll put the 8 on top. What's the only thing left in the bottom of the fraction? Just x. So that's it. That's how I would do this problem. But I gotta admit that if we didn't realize how we can pull this 8 down to the front, I can see us doing something like a little more complicated that may take us like 5 minutes. But I suggest that we see that the exponent can be brought down to the front. All right?